Hey, now it's working. Second time's the charm. All right, so for what it's worth, let's finish up 6.1, or 6.5, sorry, with example 8. 6.1, that was Janet shoveling snow. That was fun. All right, so it's evaluating a limit. The limit is x goes to 1 from which side again? Both, right, the general limit. And never not first, we try direct substitution. So notice it's x going to 1, but our numerator has t's in it as well. But it does have an x, thank goodness. Yeah, so if we plug it in, it'll be the integral from 1 to 1, which Peter Bain is what? You made the video. Don't mess up. It's 0. No, the integral is 0 because we haven't gone anywhere, right? From 1 to 1, we haven't accumulated anything because we haven't let any time expire. So it's 0 in the numerator. And in the bottom, direct substitution gives us 0. So is this a good opportunity to use L'Hopital's rule? Yep, sure is. So by L'Hopital's rule, the limit then as we approach 1 is the derivative of the top. The derivative of the integral. It's the integrand. It's the fundamental theorem of calculus part 2, right? And because we're going from plain old number to plain old x, it's just plain old integrand as a function of x. Remember the general procedure though. You plug in the top for t, so it's cosine of x times the derivative of x, which is 1, minus plug in the bottom cosine of 1 times the derivative of 1 is 0. So that's why it's gone. And the bottom is just 2x. And now we use direct substitution, and we get cosine of 1 over 2. And, yeah, that's about it. There's the answer. Yeah, cosine of, what is cosine of 1? It's a little bit greater than a half. That's all I know. Because 1 radian is about 57 degrees, which is a little bit less than 60 degrees, which is pi thirds. What's cosine of pi thirds? 1/2. And since we're a little bit lower on the unit circle, the x is a little bit bigger. So it should be a little bit bigger than a half divided by 2, which would be a little bit bigger than a fourth. But that's an exact, yeah, a fourth-ish. A fourth-ish. To be exact, cosine of 1-ish over 2-ish. Take away the issues. Yeah, so there's an exact answer. So it said here's a fun one, but maybe that was a lie. I don't know. Well, all math is fun. I was corrected this morning. All math is fun. Maybe this was a boring one, but still fun because at least it's still what? It's still math. It's not very spicy. I did. It was, yeah, here's a fun one. Yeah, there you go. All right, but it was a good review of the fundamental theorem of calculus part deux, as they say in New Orleans, right? Yeah. Okay. Any questions on L'Hopital's rule? All right, download 6.6 while I render the video.